The table shows the velocity at time t of an object moving along the line. Estimate. Keyword on here, estimate. The acceleration at t equals 6. Now, part of the reason they say to estimate here is because the function, any function is not really given to you. You're given a table, and this table is velocity, time in seconds. So if you notice, the question is about acceleration, but then the table has velocity in there. So if they had asked you what is the velocity at time equals 0, you would just put it from here. That would not be a calculus problem. It was too easy, too very straightforward. So if we were given a velocity function, t, and then they ask you something about acceleration at time equals 6, then it would definitely just be an IROC problem. You would take the derivative of velocity, which is acceleration, and then you would just plug in the 6, and you would get the exact answer. But then that would not be an estimate. That would be an exact answer. So the reason they're telling you to do an estimation is because v of t or x of t is not really given to you. You're only giving a snapshot of the velocity at particular places. So the only way that we can actually come up with the answer for this is by using AROC, using velocity to estimate the IROC if we had the function. So this is what I mean by this. So we're looking for what is the acceleration at time equals 6. Now, if I inspect the times over here, this is 4 and this is 8, so 6 falls in there somewhere. So let's plug in 0 and 18. 0 and 18 is there. I'm just making this up so you can actually understand what's going on. 4 and 16 is here. 8 and 10 is somewhere here. And 0 and 10 is somewhere there. Only snapshots. Now we're concerned between the 4 and the 18, so 4 and the 8, I'm sorry. 4 and the 8 is these 2 points right here. The 6, 4, 8, 10, the 6 is somewhere there. Now you want to figure out what the slope, because remember, this is the velocity sort of graph. We don't know what it looks like. But if this is the graph, right? Let's say it's that. Then you would really be looking for the slope, because the slope of the velocity is your acceleration. But remember, this function is not given to you, so we cannot find that particular slope. So because we cannot find the slope, the only way that we can come up with something that's close to it is by choosing these 2 points right here and say, well, you know what? Let me figure out what the slope is between these 2 points right here. And I know that it's the AROC. It's not an instantaneous. I don't really know whether it's actually a slope there. It would just be an estimate. So I'm going to compute this slope, and I'm going to give them this as my answer for the acceleration. So that's it. That's what I'm going to do. So let's figure this out, how this is done. Once you understand how this is done, it should be a very, very fast type of problem. So acceleration, it's approximately my v of 8 minus my v of 4 over 8 minus 4. Now, why didn't I use something else here? Well, the problem only has v's in there, but you can always double check this. Make up units so that you can know whether you're actually getting acceleration or not. Velocity minus velocity is really meters per second. Meters per second minus meters per second is just meters per second. And then this is 8 minus 4, that's seconds. So it's meters per second, so it's really meters per second squared, which is really a acceleration. Very quick check on whether I was on the right track solving this problem. Now, v of 8 is 10, and v of 16 is, v of 4 is 16 over 4. So this would get me a negative 6 divided by 4, which is negative 3 halves. They can twist this question in so many different ways, but it's usually an AROC problem using a table. That's all there is to it.